All right. Welcome back to day 57 of daily data structure and algorithm studies. Um, Today is my condition today is worsened, and um, I'll probably struggle to finish the stream today. But the point is, I still want to keep going, right? Regardless of how I'm feeling. So, um, let's hit it running. So, um, here is a reverse linked list question that I've started yesterday, and I could not continue because of my condition. But yeah, I'm still back at it today. I've seen a couple of solutions, but the explanations were not really clear as to what exactly has to be done to reverse a linked list from a particular position. So let's read the question. Let's read the question again and see how we can solve this. So here is reverse linked list 2, right? Yesterday I did reverse linked list 1, right? Which is an easy question. Hopefully that serves as a prerequisite for us to reverse a linked list. So let's see how we can do the reverse linked list 2. So given the head of a singly linked list and two integers left and right, where left is less or equal to right, reverse the nodes from the list reverse the nodes of the list from position left to position right and return the reverse linked list. So here is our input. We have this. So this image is just an illustration of what needs to be done. You can see we have some edge cases. I mean some input examples here. We have some input examples here to uh, perform this reversal. In reverse linked list 1, or the first reverse linked list, the normal one, the reversal was done from the head towards the tail of the linked list. But in this question, we are being asked to reverse from a particular position. Now, it could be the head, it could be the second node in the list, it could be the third node, wherever it is, wherever the left input started from, right? And the left input can be less or equal to the right input. So, how do we solve this question? Now, I've seen a couple of solutions, like I said, but let me try and see if I can explain this better. So, first of all, to reverse a linked list, right, we need to know the starting point where we want to reverse the linked list from. Now, according to this question, right, the the starting point will be the left and the end will be the right. Okay, so there is a chance that our starting point is right at the head, right? Which means it starts from the first node, or it could start from anywhere in the linked list, any node, but there is a chance that it could be from the head. And we also know the right and left pointer could be equal, right? You can see left is less or equal to right, right? So those are like some edge cases we need to see. And another thing is the number of node in the list is n, so there's going to be at least one node. So we can say for our first edge case, right, we can do this. So we can say if the right is equal to left, sorry, if the right is equal to left, then we can return, we just return the head, right? We can return the head if the right is the same as the left. But now here is where things become interesting. This is just an edge case we are trying to, avoid here. So now the real thing begins here. So I will bring this here so that I can explain it with this image. Wow, that was done at the same time. That's crazy. Ouch. So let's say this, right? Okay, so I'll take this here. So here is something I was sketching out to understand it, but there was no time. I was running out of time to stream, so let's try out this. So let's see how we can solve this question. So we want to reverse a linked list from a certain position, right? It could be, so let's take this example, right? This linked list here. Now, how do we, so the left is equal to what? Let's see. Left is 2 and right is 4, right? Left is 2 and right is 4. So the second, from the second node to the fourth node, right? So from here to here. Oh, is that what it is? Yeah, so 2 to 4, right? So this is 1, 2, 3, 4. Yeah. So 2 to 4. So we want to reverse the linked list at this position here and then return this form, right? We want to return this here, or whatever this is. So for us to do that, right, since we know where we want to start reversing our linked list from, right, we need to first of all, so we can say we keep a copy of this node here, so where the left node is, right? So here's our left node, and then we begin to swap positions, right? Now, how many times do we have to do this swap? We don't know yet, because we know that, right? We know it's going to be from left to right, right? And then from left to right is simply 2 minus, sorry, yeah, so from left to right is simply right minus left, which is also 4 minus 2, which is 2, right? So we have to iterate twice to swap every item. Now, swapping simply means, right, so from our first swap, we can take this node here, right, and then take this other node to swap their position, right? Move this node to this side and this to this side, and then take this node again, swap it with this other one here, so that we move everything in between. So here's the solution you might have come across. So we can take the current node. I'll call this CN, which is our current node at this position, right? We'll take this node and so this node is going to be like this. Let me write it out. So Cn, current node, is equal to 2, 3, 4, 5, right? Now we choose the next node in this current node, right? I'll call this the next node, or I'll say next node is simply 3, which is the current node dot next. So 3, 4, 5, right? So this is the next node. Now, what do we do here? So we'll take this, the current node's next, we'll change the next of this current node, right? We'll change it to something else. Now, what do we change it to? We'll change it to the next node of this next node here, right? The next of this next node here. So which means current node dot next will simply become this. Current node dot next will become next node, next node, next node dot next, right? Next node dot next is this from here to here, right? So which means our current node is now like this. So it's now 2 2 so the next has changed now, so 2 4 5 like this, right? Oh god. So we've changed the next node, the next of our current node, right? Which is quite similar to the way we reverse a normal linked list, right? So we take the current node, we choose the next node in the linked list, right? The next node is this, the next node of the current node, and the current node is simply where our left pointer is, right? So the left. So we take the next node of our current node, or where the left position is, right? And then set the next, or change the next, right? Change this to this. So we'll change this to the next of this current node, of this next node. You know what? Let me not call it next node because it sounds somehow. So for most of the solution I've seen, it's called temp, right? So I'll call it temp instead. So I'll say temp, which is just a temporary node. Temp is simply going to be equal to the next of the current node, which is 3 3. That's a very long arrow. 3 4 and then 5, like this, right? So we know we have our next node, our current node. Let me refresh this again. Sorry, my stream is lagging a bit, so I need to refresh it. So we take the next node in our temporary node, right? I mean, we take the next node of our, where our left is, right? Set it to the temporary node. Now we want to change the current node here, right? The next items the next node that follow the current node to this temporary node's next value. So we'll say, let me move this downwards, even to the right, like this. So we'll say our current node, let me shift to this side. Current node dot next should be equal to the temp dot next, right? So which means our current node will become something like this. I'll use a different color. I'll say 2 4 and then 5, like this, right? So after we've done that, right, you can see we are beginning to move the left, the where the right pointer would be, towards the position where the left pointer is. So we are simply swapping it slowly. We are moving one node at a time. So then we'll take the temp node, right? We'll take the temp node and we'll set its next value, right? The next value of this temp node. So the temp node is from 3 all the way to this side. We'll set the next value of this temp node. So we'll set the temp value of this next node to the node here, right? The next value we'll set the next value of this temp node to this node's next value. So this node's next value is 3. Temp node is this. So we'll move all of this back to this side. This question is a bit tricky. What did I just say? Oh my god, my waist. Okay, so we want to switch the node in between, right? We want to move one node from the right to the next. We want to swap everything until we reach where the right position is. So the temp node next value, right? This temp node's next value is this 4, 5, and so on, right? We want to set the next value of this node, right? Of this temp node to something else. And what would that be? Ouch. Ooh, sorry. Um, temp.next is going to be equal to, want to swap, um, we should swap it to, this point here. So we can take this. We know we started from this. The current node is this, right? So we can say temp node.next should be equal to this. So temp node should be equal .next should be equal to the current node. This is a bit tricky. Current node. Which is current node. So current node, we know current node has changed to this. So our temp node will be looking like this at the end of the day. 3, 2, 4, 5, right? Like this. And then we can say the next node of this current node here should simply become the next node of our. There are a lot of steps involved in this thing, though. I'm just explaining from the solution I saw, but it's quite confusing how many steps are involved into solving this question. But you know what? Let's even go back to normal normal operation, right? We know if we want to swap every value in this node, right? We want to swap everything here. We will have to move the nodes one after the other, right? Which means this node here has to come here, right? So 2 will move to this point and then we'll move back to this side. So we can move 2 to here, right? And then move 4 to here. Now when we move 2 to here, 3 will come to this side, right? 3 will come to this side. 3 will come to this side. 2 will be here, and then 4 will be here. So in the next, it's not going to be the next iteration, but in the same operation, right? We can then move 2 to this side and then 4 back. So we can move. So we'll have 3, and then we'll move 3 to here, right? So we'll have 3, 4, and then 2 here, right? And then we'll now swap these 2 again. So we'll swap 3 with 4. So 3 with 4 will become 3 with 4 will move like this. So we'll say, let me just trace this like this. 3 with 4 will move to 4, 3 back, and then 2, right? And with that, we swapped the positions. But let me go over this again because the steps are beginning to take shape. So we take the first node. So let's say our swap are done here, right? So we take this node, or in fact we swap this first node, right? This node with this node, right? So it will become like this. It will become 3, 2, and then 4, right? And then the next swap we have to do is to move 2 to this side again. So we have 3, 4, right? And then 2. 2 is at the end now. So we move 4 back to this side. So we have 4, 3, and then 2. Like that. The swapping steps are quite tricky in the sense that we are not swapping from the head to the tail. and we are not swapping. Yes, so we are not swapping from the head to the tail, and then we don't know, you know, um, hmm, I thought I got this, but let's see. Ideally, right, if we're to swap these nodes, sorry, if we're to swap these nodes here, right, when we take this node, right, we take the next value. So our temp should be here, right, which is our temporary node. Now we want the next value of this node to be 4, from 4 going, right. The next value of this node should be the next of our temp node. So that's what we need to do. So we'll say this will become something like this. So we'll have 1, 2, and then the next value here will be 4, the next of the temp, right, 4, 5, right, 4, 5. And we know temp is at this point, right, temp is at node 3. So in the next iteration, not in the next iteration per se, but like we also want the next node of the temp to become the copied node of the current node, right, the copy of the current node. Oh god, I'm not feeling really well. I don't know what I'm saying. Um, so let's say the temp node is a pointer, right? That points to the node after the current node here. The current node is at this point. Now, when we iterate through, or when we traverse every node in the linked list, right? When we traverse every node in the linked list, we want to move the god. We want to move the we want to set the next to the next node after the next of the current node, the next node of this current node here, to the node after the temporary node, right? And then oh jeez, I don't know, I'm falling out. Sorry. Oh Jesus, I thought I got it, but honestly I did not. I'm in extreme pain right now. You know what, let me I've seen the solution, right, but I tried to understand it, which I did, but I don't know, I'm not feeling well at all. I think I'll have to end the stream now. Sorry, my body is rejecting everything I'm doing right now. I'll probably come back stronger tomorrow. I am so sorry. This stream did not go as planned at all. I wanted to explain better all the solutions, but I can't continue.